Welcome to the video lecture series on principles of compiler design. This is Dr.K.N.Sivabalan, and today's video lecture will be learning about the specification of tokens, the most significant topic in principles of compiler design. Now, the first notion we are supposed to learn here is called as alphabets. So, what is meant by alphabet? It's not traditionally connected with English alphabets. So, alphabets in theory of computation notation is very different from what you learn from English alphabets. So, a finite set of symbols is called as alphabet. So, any symbol which will be considered as an alphabet, say for example, zeros and ones, plus, minus, any sort of symbols, including A, B, C, D, everything is considered as alphabets here. For instance, a set of alphabets will be denoted by a mathematical symbol called a sigma. Sigma, in this case, we have 0 and 1. So, we have two alphabets, 0 and 1. So, this is called as binary alphabet. And sigma can also be said as a set of alphabets spanning from A to Z. All these are called as lowercase alphabets. Also have capital case alphabets also. Now, what is meant by a string? A finite set of symbols generated over an alphabet is called a string. For instance, here we have a set of alphabets as 0 and 1. Now, when we try to generate repeatedly using the zeros and 1 symbols, we get a string. For instance, when I substitute this symbols repeatedly, I'll get 0, 1, 0, 0, 1, 1, 1, 1, 0, 1, so on and so forth. So it will get repeatedly. You can apply only these two symbols as far as this alphabet is concerned. So this concept is called a string. And what is meant by the operations of the string? So we'll be learning about the various kinds of operations of the string. So operations of the string spanning from length of the string, empty string, prefix of the string, suffix of the string up to substring. So we will be elaborately discussing with suitable examples about these concepts. So length of string. So what is meant by length of string? The set of symbols inside a string is called as length of the string. It is actually flanked by two vertical bars. Let us imagine that W is called as a string. So W is symbolically made as a notation for string here. When we flank it by two vertical bars, that is called as the length of the string. So in this case, W we have 0, 1, and 0. So altogether there are 4 symbols here. So when I find the length of string, then it is equal to 4. So the number of symbols present inside the string is called as length of the string. Now, an empty string is actually denoted by epsilon. So when we mark a notation with epsilon, that means it is actually denoting an empty string. So the next is called as a prefix of the string. So all the leading symbols in a string is called as prefix of the string. In this case, we have W equal to AA and BB. Okay, and in this case, we can have epsilon as a prefix, AA, BB as a prefix, A, AA, AAB. Now you can see here, all will be wondering, you will be perplexed to note that there is sigma, there is an epsilon and AAB as a prefix here. How come? For instance, when you take the string called as AABB, you can also assume that there is an epsilon before this AABB. So presence of epsilon does not change the string. And similarly, you can also note that an epsilon is after the string AABB. So in this case, when you take the first string epsilon AABB, you can note that all the leading spaces, so all the leading symbols, so leading symbol is epsilon, so epsilon is called as a prefix. When you take the second string AABB epsilon, you can see that the leading symbols here is AABB is called as a leading string. So in this both cases, that's why you have epsilon and AABB as a leading string symbols here. So this is called as a prefix. The next one. Now, what is meant by proper prefix? So when we ignore this epsilon and AABB, then it is called as a proper prefix of a string. So I take every symbol except epsilon and AABB. So that is called as a proper prefix. Now, what is meant by suffix? Suffix is called as all the trailing symbols on a string is called a suffix. For instance, when you take a string called as w equal to 0, 1, 0, 0, then the suffix is all the trailing symbols. The trailing symbols are actually coming from the right end. Right end means you can have epsilon, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0. Now, how will you get this epsilon? So, similar to the topic which we have discussed earlier on the prefix, you can say that 0, 1, 0, 0 can be leading with epsilon and it also can be trailing with. When we take the second string where the epsilon is trailing, you can say that epsilon is called as a trailing space. When you take the first string where epsilon is leading, then the trailing symbols are 0, 1, 0, 0. So that's what it is written as epsilon 0, 1, 0, 0. Now, what is meant by a proper suffix here? When we just ignore this epsilon and the whole string, then it is called as a proper suffix. Now, what is meant by substring? So, substring is called as a part of the string. In other words, when we try to delete the prefix and suffix of the string, then that is called as a substring. So anything which forms of the part of the string, that is called as a substring. For instance, we take W equal to SKCT. SKCT is called as a string here. Then the substring is anything which is part of that. For instance, epsilon is a part, SKCT is called as a part, KCE is a part, CE is a part, KC is a part. Okay. Now, except epsilon and SKCT when it is getting removed, then that is called as a proper substring. So, anything which is part of the string is called as a substring here. Now, concatenation of the string. So, when you try to merge more than one strings together, then that is called as a concatenation of the string. In this case, we have taken two examples. W1, it consists of A double B and W2 consists of C double D. So when we concatenate W1 with W2, that means W1 is actually preceding and W2 is actually following. In that case, you get a string called as ABBCDD. Suppose if I do vice versa, that means W2 is actually proceeding and W1 is following, I will get the answer called as CDDABB. So depending upon the order of concatenation, the result actually changes. And what is meant by a language? A set of strings generated over sigma is called as a language. Let us assume that we have three alphabets called as ABC. Then the language L can be generated repeatedly by applying these three symbols. So ABC, AB, BC, ABC, so on and so forth. If you can apply these three symbols any number of times to generate a language. Now, the operation of the languages. The operations of the languages called as union, concatenation, cleans closure, and positive closure. Now, what is meant by union? Union is actually, you have learned in school level mathematics, you have two sets and you can incorporate these two sets into one set if element is existing in both the sets or if it is existing in at least one set. So, in this case, you have L is one set which consists of 0, 0 and 1, 1 and M has AA and BB. Now, when we merge it together, so we have together elements called as 0, 0, 1, 1, AA, BB. L union of M. Now, mathematically it can be defined as the entire result is actually specified as S. Now, this S can be either in L or it can be in M. So that's what it is written in the mathematical notation as L union of M is equal to S, where S is in L or S is in M. Now, we go for the concatenation. So merging of two languages is called as concatenation. So let us assume that L is equal to 0, 1 and M is equal to 0, 1, 1, 1. Now when we merge it together just like cross multiplication, so when 0 is actually merged with the rest of the parts of M, you will get 0, 0, 1 and 0, 1, 1, 1, 0, 1 and 1, 1, 1. Let the language generated in S is then, so S can be mathematically applied as S is actually present in L as well as it is present in M. So this is how actually you can get a concatenation symbol. Now the Kleene closure is also called as star notation. We have a Kleene closure. We have a Kleene closure here. Now, in this Kleene closure, when you have a sigma is equal to A, then sigma star can be represented as 0 or more number of occurrences. So when you have anything with 0 or more number of occurrences, then it is called as a Kleene closure. So when a symbol appears 0 times, obviously epsilon will be generated. That's why when A is getting generated 0 times, it is getting epsilon. Then A is getting generated 1 time A. When it gets generated 2 times A, so on and continues. So mathematically we can define this Kleene closure as L star union of, so I varies from 0 to infinity, and L is actually represented as L to the power of 5. Now the next is called as positive closure. So positive closure means there's a small change here. It is 1 or more number of occurrences. It is 1 or more number of occurrences. Okay, so minimum you should start from 1 and it can go up to infinity. So at least A will be generated here 1 time, minimum 1 time, and maximum it can be generated n number of times. So that's why L plus positive closure has been represented as I is equal to 1 and I is equal to infinity L to the power of 5. So there's a small change here. Positive closure means it's not 0, it should be represented as 1. Positive closure means 1 or more number of occurrences. And the regular expression. So what is meant by regular expression? A regular expression has been mathematically defined as a sigma. It is defined as a pi is called as a regular expression for empty set. Epsilon is a regular expression for null string. And if A is a symbol in sigma, then regular expression is A. And if you have two regular expressions R and S, then union of regular expression is regular expression. Concatenation of regular expression is also regular expression, and Kleene closure of regular expression is also a regular expression. So all these three operations will be closed under regular expressions. That is union, concatenation, and Kleene closure. Now the algebraic laws of regular expressions are R plus is equal to S plus R. So just like it's called as commutative law. R plus S plus T can be represented as R plus enclosed with S plus T. Rs of T, it's called as concatenation, can be made as R S of T here. R plus S T equal to RT plus ST. It can be abbreviated as it is. Epsilon into R equal to R into epsilon will always result in R. R star can be written as epsilon plus R to the power of whole star. R star star can also be written as R star. So all these laws put together are called as algebraic laws of regular expression. Now the meta characters of regular expressions is when you have A, when you write A, that means it matches all the character of A. When you put dot, it matches any character inside a string. When you put R star, 0 or more number of occurrences. R plus means 1 or more number of occurrences. R question mark, that means a regular expression can appear 0 or 1 number of times. So it will be confined within 0 and 1. And when I put a cap symbol, it is called as it matches to the beginning of the line. And when a dollar is used in a regular expression, it means that anything which is ending with a particular string, you will be made a match over here. R1 bar R2 will be alternative representation of R1 or R2 will be occurring. When I put A, B, C in square brackets, occurrence of any character A, B and C at least it appears only one time. It appears only one time. Either it will appear A or B or C. Now what is meant by regular definition? So regular definition is called as the naming of the regular expression is called as regular definition. So in this case, I have named a regular expression as an identifier and I have written the rules over here. So identifier should start with a letter and it can be followed by a letter or digit any number of times. And letter can be a capital alphabet to capital alphabet, capital Z, or it can be a small alphabet or smaller up to small alphabet Z, or it can have a combinations of both these two, capital and small letters can appear in combination. And digits you can have from 0 to 9, spanning from 0 to 9, it is called as digits. So every notation should be represented with the meaning of it using a regular expression, and this is called as rules. When you just name the rules, that is called as the regular definition of regular expressions. So thanks for watching a video. Have a good day.